The South Indian state of Kerala is famous for coconut production, and its soil and environment is most suited for it. The state produces approximately 45% of entire India's coconut production. In 1970, this area suffered a severe problem of coconut root wilt disease, which very badly affected the yield. Identification of the disease required a skilled person to climb each and every tree and inspect the canopies. As this method was very tedious and time-consuming, an ISRO scientist, Professor Pisharati, successfully carried out a path-breaking experiment for detecting this using color infrared aerial photography from a helicopter. As the field of view from the helicopter was relatively small, and even this method proved to be time-consuming and expensive. This triggered the idea of carrying out such observations from a satellite, and thus the Indian Remote Sensing Satellite Program IRSP was conceived. In simple terms, remote sensing means getting information about an object by observation made at a distance without coming in contact with the object. The satellite which carries out this function is called a remote sensing satellite or Earth observation satellite. Depending on the height of the satellite above the Earth, it can see a much larger area and make remote sensing a viable and an optimal solution for such observations. When a satellite carries out remote sensing of the Earth, it is also called Earth observation satellite. Now, the question is, how does a satellite do this? Let's take our own example. Humans have 5 senses of seeing, hearing, smelling, touch and taste, which is gathered through our sensory organs and analyzed by our brain. Similarly, a remote sensing satellite has cameras to see and many other types of sensors for gathering various types of information. Modern-day science permits us to make many types of sensors. For example, we see through our eyes by sensing visible light, which is one part of electromagnetic spectrum. If we go to other part of this spectrum at higher frequencies like X-rays, we all know we can even see bones and other parts within our bodies. Similarly, our satellite sensors are designed to use various means to observe many different parameters like water vapor, temperature, wind speed and many more. The information so gathered by these sensors is processed and analyzed through computers and other instruments in a way which is easily understood by us. A complete Earth observation system thus has 2 basic components: space segment, which is the satellite, and other, the ground segment. The ground segment receives and sends data from and to the satellite, maintains satellite in proper orbit, and also monitors its health. Ground segments are today equipped with networks of radars, antennas and computers to facilitate the task. Since ISRO started the remote sensing program, various user segments like agriculturists, forestry, town developers, agencies managing disasters, meteorologists and many others projected more and more needs. ISRO was thus driven by the user needs to develop the program further. The first operational Indian remote sensing satellite, IRS-1A, was launched in March 1988. This was followed by IRS-1B, IRS-1C, IRS-1D, OceanSat-1 and OceanSat-2, SARAL, CartoSat-1, RISAT and many more. All of these satellites are placed in a low Earth orbit and they move with respect to Earth in a periodic way. If a satellite is placed at the height of 36,000 kilometers over the equator, it moves with same angular velocity as Earth and thus appears stationary from Earth. These are called geostationary satellites. From this height, though we see a larger area of the Earth, the resolution of image is less. Thus, the choice of satellite height is essentially decided by the type of observation to be made. India also has dedicated a series of geostationary satellites of INSAT series for the remote sensing of weather. Currently, 3 such satellites, INSAT 3D, INSAT 3A and Kalpana 1 are also operational. Today, our fleet of Earth observation satellites provide very useful information on crop forecasting, potable groundwater sources, disaster management, weather prediction, land use, forestry, air quality monitoring for public health, climate change detection, groundwater hydrology, forest fire monitoring, early warning for flood and cyclones, oceanography, marine resources, coral problems, fisheries and coastal management. The ResourceSat and RISAT series addresses needs for agriculture, land and water resources management. CartoSat series addresses the requirement of detailed mapping of land, and the OceanSat series addresses observation of the oceans for cyclones, atmosphere-ocean interaction and meteorology. India is one of the most disaster-prone countries in the world. 57% of our land is vulnerable to earthquakes, 68% to drought, 12% to floods and 8% is vulnerable to cyclones. The Earth observation satellites contribute towards disaster management support service in a very meaningful way. Imageries from our satellites provide necessary inputs on coming natural calamities like cyclones and heavy rains, etc. Satellite images of pre- and post-disasters are also used for implementing long-term mitigation plans. The applications of Earth observation satellites are endless. Team ISRO is committed for serving the nation's needs and continuously work to improve the life of citizens, to keep you smiling all the time.